So we're going to take a look here at how some of the seismic and fluvial or river processes interact to produce some of the most iconic features that show the offset along the San Andreas Fault in California. So to do that, we're going to come into this area known as the Carrizo Plain, which is found in this part of California. So let's get a little bit of the context of this area first of all. You can see that there are a number of streams that flow in off the upland area just to the side of the plain here. But you'll notice that as these streams come down, they seem to just disappear. They don't seem to flow into a river. Where's the river gone? Well, this is a result of the type of climate that you've got in this part of California. The input of rainfall is very, very low, so you don't get necessarily constant flow down in these streams here. And the output is very, very high of water because the temperatures are so hot. So what basically happens is that you will get flash floods happening. You will get these gullies that are eroded by the flash floods. The water will come down into here and it will gather in the basin in the Carrizo Plain, and then it slowly evaporates off. You can see a little bit of a lake here, but it leaves behind these salt plains. So the rainfall here tends to be producing these flash floods, which means that you're not getting this constant flow of water. But it does mean that whenever you do get flow of water coming down here, that you do have quite a lot of erosive power in this little area. So that's a little bit of the fluvial context. The seismic context, this red line here shows the San Andreas Fault. This part here is moving to the northwest. This part here is moving to the southeast. So what you're getting here is this constant movement, and the constant movement manifests itself in some of the impacts in the streams. What's happening here is this stream that comes down is that it's getting offset. You're getting a sudden change in direction here because this plate is moving in this direction, this plate is moving in this direction. And basically what you'll get is an earthquake which will jolt or move the plates here at this point and jolt those out of shape. So that's a little bit of the seismic and tectonic processes that are happening. But what we want to do is to figure out what's happening in particular here, how these interact to produce these features. This is known as Wallace Creek, and at present you can go and visit. There's a few cars parked in there. You walk up here and what you will see is this offset here. The stream comes down, then it takes a very, very sudden turn to the right and then comes down here. So that's your offset. If, however, you walk further down here a little bit, you will find former creeks here. There's no longer any water is flowing in them, and that is previously connected here. So what's happened is that this is the current position, but some processes have occurred that have offset it in that direction as well. Now what we need to try and do is to figure out what those processes are. So let's have a wee look. So this little diagram here is illustrating and demonstrating what's going on. There's the older channel, there's it offset. So this is the bit in blue here, what it looks like here. And then this will get cut off somehow. A new channel will form and it'll be cut off as well. So what are the processes at work that produce that? Let's take a look at these series of diagrams here. So this is the interaction of the seismic processes and the fluvial or river processes to create these landscapes. In the first instance, you've got the fault running along here, marked by this line. So that gives you a build-up of seismic stress as the plates are moving in either direction, but the fault is locked by friction. So you're building up and building up of stress, but all suddenly and eventually that friction will be overcome by the seismic stress, and you will get that sudden movement. When you get the sudden movement, you get these plates being offset in relation to each other, and you get this sudden change in the location of the stream where it's cut off or offset like that. And in that instance, what happens then is that the river flows along the fault line from A to B. So it's coming down here, then flowing downhill and flowing along here. And that's the offset that we have seen in the likes of this position here. However, over time, as you get a series of other earthquakes here, the offset is increased even further. The distance between A and B increases even further. Now, as you increase the distance without changing the height, What are you going to do to gradient? You increase the distance without changing the drop in height. You're going to reduce the gradient. The gradient is getting lower and lower and lower. Now I wonder, can you figure out what happens next? Remember I said that this area is dominated by flash floods, and that means that a lot of the time there's not very much water, if any water at all, in the channel, and then there'll be a sudden storm. You will get a lot of water coming down here with a lot of erosive power. Now eventually it'll get to the point where that angle there is so gentle, rivers will always find the most efficient way downstream, that it actually cuts a new channel. And whenever it cuts that new channel, here you go, it's a more efficient channel coming down here as a result of those processes going on. And what then happens is that this channel over here at B is, as it is called, beheaded. This is a river without a source. Oh, what's happened? Well, the source is up there, and then that whole process will start all over again, and you will get subsequent earthquakes that will offset it, and so on and so forth. Now that's what we're seeing in operation here. We're seeing this former channel that has been offset, and you're seeing here, and now is beheaded. Now you're seeing the new channel has been formed and is moving on there a little bit as well. So that's how you get the interaction of your fluvial and seismic processes to produce the fascinating landforms at Carrizo Plain.